All right, part 3. Number 21, multiplying. All right, let's see. We can make these rational exponents, 9/4, x to the 9/4, times x to the 1/3. Because once we do that, now we can use our exponent rules. Since we're multiplying, we would add our exponents. So this would be equal to x to the 9/4 plus 1/3. So I've got to add 9/4 plus 1/3. I need a common denominator. So that one times 3 over 3. This one times 4 over 4. That gives us 27/12 plus 4/12 is 31/12. So x to the 31/12, and then I'm going to now put it back as a radical. 12th root of x to the 31 . Did I mess up? 4th root of 9, x root of 3. I have something different on my... Oh, it's a 9. I wrote it wrong, didn't I? Oh, I did on my answer key. So I'm a goober, and on the answer key that I posted for you guys, I accidentally wrote 4/9. So then I added 4/9 and 1/3, which of course is a totally different number than 9/4 plus 1/3. So now I'm going to simplify this guy. So sorry about that. I'll have to make a note on the teams or something. 31. So we could have x to the 12th. X to the 12th, that's 24. And then 24 to 31 is 7. 12 plus 12 plus 7 is 31. So the 12th root of x to the 12th is x. The 12th root of x to the 12th is x. And then that guy's left inside. So x squared, these guys are on the outside, times the 12th root of x to the 7th. So I was going to mention that how you know when you can simplify these is when your exponent on the inside is larger than the index. Then you know you can do this to simplify it. All right, our radicals, and now we're graphing. So if you remember how these work, it would be like the parent or the graphing form. X plus h plus k. So that we got that opposite same thing going on again. So this graph doesn't have an outside number, it's just plus 0. So it's only moving to the right 3 from the parent, where the parent would be at 0, 0. So we're going 1, 2, 3 to the right. And then the way you can pop it in your graphing calculator, or you can plug in numbers. So if I plug in a 4, because 4 is just to the right of 3, 4 minus 3 is 1. The square root of 1 is 1. And then the next number over, I'm gonna plug in a 7, because 7 minus 3 is 4, and 4 is a perfect square. So 7 minus 3 is 4. The square root of 4 is 2. So over 7, up 2. And then my next perfect square number would be 9. So that means I would have to plug in x as a 12. 12 minus 3 is 9. The square root of 9 is 3. So if I go over 12, then it's up at 3. There we go. and I know it doesn't say it, but just for the review of it, domain and range, domain x such that x is greater than or equal to 3. It's only on the right of 3. And our range, y such that y is greater than or equal to 0. Number 23. Translate 2 units down and 3 units to the right. Okay, so our x cube function, the parent, goes like this. If you'll remember, that does this little s kind of a thing. And because you think about plugging numbers into that, if I plug in a 0, I get 0. Cube root of 0 is 0. If I plug in a 1, cube root of 1 is 1. And then my next perfect cube is an 8. So if I plug in an 8, the cube root of 8 is 2. So it's going over 1, up 1, over 8, up 2. And then the same thing on the other side, just in the negative direction. Left 1, down 1, left 8, down 2. And that's our parent. So now we're moving that. So I'm going to do it from that inflection point there. I'm going to move it 2 units down and 3 units to the right. 2 down, 1, 2, 3 to the right. So that's my new inflection point. So it goes over 1, up 1, over 2, 4, 6, 8, up 2. This is the right leg. And then the other side does that, but down and to the left. Over 1, down 1. Over 2, 4, 6, 8, down 2. You can also, what was I going to say? I don't remember, but you could put this in your graphing calculator and that it would have graphed that, and you would be able to see, go to the table, and it'll tell you the numbers, and so then you can make the adjustments to move it 2 units down and 3 to the right. Let's see, solve. All right, we've got like terms here, so before I do anything, I am gonna combine those like terms. So subtract 8 both sides. Now we have the square root of 3x plus 7 is equal to 7. And now to get rid of that square root, we would square both sides. The squaring undoes the square root, leaving just the 3x plus 7 on the left. And 7 squared is 49 on the right. And I'm going to minus 7 both sides. So 3x is equal to 42. Divide both sides by 3, and we get x is 14. Solve. Woohoo! Another solve. So this is a radical also. Remember, we could write that as the cube root of that squared. We don't have to, but I'm just reminding you what it is. We don't have to because what we could do is use our power rules. We're going to take both sides to the power of the reciprocal of 2/3, 3/2. Because when you take a power to another power, you multiply those powers. And when I multiply 2/3 with its reciprocal 3/2, I get 1. And something to the 1 power is just itself. So this whole side is now just that to the 1 power, which is just that. So I don't really need those parentheses, do I? Equals, now, what's 4 to the 3/2? Remember that means the square root of 4 to the 3rd. I can write it like that, or I can write it as the square root of 4 to the 3rd, because this way I don't have to think as hard. Well, I guess they're both about the same. But the square root of 4 is 2, 2 to the third is 8. So that side is 8. If I did it this way, I would cube first. 4 cubed is 64. The square root of 64 is 8. So I guess they were both the same level of difficulty. All right, quadratic. So I want to get everything on one side. So let's minus 8. X squared minus 4x minus 5 equals 0. And now I can factor it. If it doesn't factor, you can complete the square, use the quadratic formula, but it turns out this is going to factor. We would have a minus 5 and a plus 1. That to multiply to negative 5, add to negative 4. So x minus 5 equals 0, and x plus 1 equals 0. Add 5 both sides, minus 1 both sides. X is 5 and negative 1. Number 26. Find f of x plus g of x. We're just adding. So we're taking this guy and we're adding it with that guy. 10x squared minus 6x plus 20. That's it. Now we are subtracting. So I'm taking f of x and I'm going to subtract g of x. That means I would have to distribute that minus. So we're going to have 7x squared plus 3x minus 4 minus 3x squared plus 9x, because minus negative is plus, minus 24. So now I'm looking at those guys when I combine my like terms. 7x squared minus 3x squared is 4x squared. 3x plus 9x is 12x. And where am I? Negative 4 minus 24 is minus 28. 28. G of h and h of g. So when I see it written like this, I like to write it like this. Because this one tells you, when you write it this way, it tells you which one goes inside the other one. So my g is first. So I copy down g with a big set of parentheses where the x is. And then inside those parentheses, I'm putting h in there. H is 2x plus 5. Then you just do whatever it looks like you need to do. That's a distribute. 7 times 2x plus 5, so I'm going to simplify it out. 7 times 2x is 14x plus 35. So that's our g of h of x. Now we need to do h of g of x. So h comes first, so I'm going to copy down my h with parentheses where the x is. And inside those parentheses, we're putting g in there. G is 7x. So for this one, we just have to multiply there. 2 times 7x is 14x. Then we got our plus 5. And that's that on that one. 29. Find the inverse. Okay, excuse me, inverse. So first we write the f of x as a y, and then we do our switcheroo, make the x a y and make the y an x and make the x a y. So we did the switch and now we solve it for y. So I would minus 4 both sides. So x minus 4 equals negative 5y. I'm going to flip them around. So when I solve for something, I like it to be on the left. And now I'm going to divide both sides by negative 5. So there's two ways you could write it. X minus 4 over negative 5, which is fine. Or if you did the division, they both get divided by negative 5. So we would have negative x over 5 plus 4/5. negative over negative is positive. Or I guess another way you could write that first one would be negative 1/5 x plus 4/5. So either any of these is going to be fine. Probably easiest just to leave it like that one. But it's multiple choice, so you're going to have to be able to recognize different forms of things. So that is it for part 3. Oh, thank goodness I'm still recording. I thought it freaked out, and that was all a big waste. Anyway, that's part 3.